Hello, you're watching EasyMathVideos channel, and today we are going to learn about Euclid's division algorithm. So what does Euclid's division algorithm say? It says, given two positive integers a and b, there exist unique pair of integers q and r satisfying the equation a is equal to bq plus r, where 0 less than or equal to r less than b. For example, if we take a as 25 and b as 8, we can write 25 equals 8 multiplied by 3 plus 1. Therefore, we get q is 3 and r is 1. If we take a is equal to 47 and b is equal to 5, we can write 47 equals 5 multiplied by 9 plus 2. Therefore, q is equal to 9 and r is equal to 2. So we have a few more examples here. A equals 9 and b equals 6. We can write 9 equals 6 multiplied by 1 plus 3. Q is equal to 1 and r is equal to 3. So a equals 5 and b is equal to 15. We can write it as 5 equals 15 multiplied by 0 plus 5. So q is equal to 0 and r is equal to 5. In all these above examples, q is the quotient and r is the remainder when a is divided by b. So in this example we have, when 9 is divided by 6, we get a quotient of 1 and a remainder of 3. When 5 is multiplied, we get a quotient of 0 and a remainder of 5. Now we see how to apply Euclid's division algorithm to find the highest common factor of two numbers. So for example, let us find the highest common factor of 40 and 16. Let us first express the given numbers as an equation a is equal to bq plus r. So first we divide 40 by 16. So we get a quotient of 2 and a remainder of 8. So we write the equation as 40 equals 16 multiplied by 2 plus 8. In the next step, we take 16 as a and 8 as b and write the same equation. So we get 16 divided by 8 is 2 and the remainder is 0. So we get 16 equals 8 multiplied by 2 plus 0. And when we get 0 here, we stop. Now the highest common factor of the given numbers will be the b we use in the last equation. The last equation was 16 equals 8 multiplied by 2 plus 0, and the b in this equation is 8. Therefore, the highest common factor of the given two numbers 40 and 16 is 8. So now we do another example. Find the highest common factor of 49 and 35. We write the equation a is equal to bq plus r till we get a remainder 0. So step 1, 49 equals 35 multiplied by 1 plus 14. Now we take 35 as a and 14 as b, and we write 35 equals 14 multiplied by 2 plus 7. The next step, we take 14 as a and 7 as b and write 14 equals 7 multiplied by 2 plus 0. Now we get a 0 here, so we stop. And the last b we use is 7. Therefore, the highest common factor of 49 and 35 is 7. So in the same way, we can find the highest common factor of 1860 and 2015. So these are the steps. Please use a pen and paper and work it out yourself and check if you get the right answer. I hope you got it. Yeah. So we proceed to do a more complex problem using Euclid's division algorithm. So the problem states, use Euclid's division algorithm to show that the cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. So first let a be any positive integer and b be 9. Now according to Euclid's division algorithm, we can express a as bq plus r, where 0 less than or equal to r less than b. So here we are taking b as 9, therefore we get A equals 9q plus r, where 0 less than or equal to r less than 9. Therefore, A can be expressed as 9q, 9q plus 1, 9q plus 2 and so on up to 9q plus 8. Now, the problem says the cube of any positive integer. So, we take a cube, and a cube can be expressed as 9q cubed, 9q plus 1 cubed, 9q plus 2 cubed and so on up to 9q plus 8 cubed. Now, to find a cubed, we expand each of these expressions 1 through 9 using the formula a plus b cubed is equal to a cube plus b cube plus 3a square b plus 3ab square. This is something you might have learnt in your earlier classes. Therefore, the expression 1 becomes 729q cubed. If we take 9 out, it becomes 9 into 81q cubed. If we take 81q cubed as m, this expression can be written as 9m. Next, we expand 9q plus 1, the whole cubed. This becomes 729q cubed plus 1 plus 243q squared plus 27q. We take this 1 away and we take 9 out here. Therefore, we get 9 multiplied by 81q cubed plus 27q squared plus 3q plus 1. If we keep 81q cubed plus 27q squared plus 3q as m, then this expression becomes 9m plus 1. Next, we simplify 9q plus 2 the whole cubed in the same way. Here we get an 8. So, we take this 8 out and then we take the 9 outside the bracket and write this as 9 multiplied by 81q cubed plus 54q squared plus 12q. And if we take this expression 81q cubed plus 54q squared plus 12q as m, this expression becomes 9m plus 8. Similarly, we solve 9q plus 3 the whole cubed and we can simplify it as 9m. We do the remaining expressions in the same way. Please pause the video, use a pen and paper and expand each of these expressions and see if you are getting the same answer. When we are done, we can see that all these expressions can be simplified as either 9m or 9m plus 8 or 9m plus 1. We don't get 9m plus 2 or 9m plus 4 or 9m plus 7. We don't get any of these expressions. Therefore, we can prove that the cube of any positive integer can be expressed as 9m, 9m plus 1 or 9m plus 8. That's all for now. Thanks for watching and please leave your comments or questions. Thank you.